Alright, this is going to cover 1.1.4 and 1.2.4, which is basically not working with nonlinear functions. For HSA algebra, we don't study the actual equations and things like that of functions that are higher than degree 1, which is a linear function. So what we just need to look for is being able to identify maxima and minima, zeros or roots of a function, functions that are either continuous or discontinuous, and I think that's it. Maybe whether to define if it's a function or not, we're using the vertical line test. But we're not really concerned with the equation. So here we're just going to be looking at the graph, reading the graph, and understanding some of those basic points about it. So use this as an example. So it says, look at the function that's graphed below. What are the zeros of the function? Well, the zero is the value of x that makes the, the input that makes the output, or f of x, equal. So if you were to substitute the number where it crosses the x-axis, you would get 0 as an answer for y. So we see that it crosses the x-axis at 3, crosses the x-axis at 1, and crosses the x-axis at 5. So it has 3 zeros, and they are 3, or negative 3. That should be a negative. The copy and paste from the picture didn't take. So it's negative 3, 1, and 5. So that is our answer. Alright. 2, just to discount the other 3. 2, that's where the graph crosses the y-axis, so we can call it the y-intercept. 1 and 3, well, those are 2 of the zeros, not all of them. 4, or negative 4 and 4. Negative 4 and 4 are what we would call the local min and the local max. Alright, so we know that the graph goes higher than 4. I can prove it to you right here. It hits 6. But this does have a point on the graph where it stops increasing and it begins to decrease again. We call that a local maximum because, again, the graph does obtain a higher value than 4. Same thing with negative 4. We call that our local minimum. Alright, so if the question, just for HSA algebra purposes, were to ask what is the minimum of this function, alright, negative 4 would be an answer. But again, we're not looking at minimum maximum, we're looking at the zeros, the values of x that make y 0. So basically where it crosses the x-axis. And they're negative 3, 1, and 5. The graph below models the relationship between the ticket price for a concert and the expected profits. Which of these best describes the zeros of this function? Another zeros question, so let's find them first. Okay? Alright, so this says this x values are the ticket price in dollars, and the y values are the profit that you make selling tickets at that price. Alright, so let's see. We know 9's not a 0. 9's a maximum. And that's a true maximum for this function. So 9 is not the 0, but it does indicate when the profit is at a maximum. So if we sold tickets at $9 a piece, the maximum amount of money we'd make is $18,000. Okay, so we'd want that, but that's not what the question's about. So it's not A. B, negative 12,000 is the 0? No, that's where this function would cross the y-axis. And so that's not the answer. 2 and 16 are the zeros. They are. And they indicate the ticket price for which the profit is $0. That seems to be the one. Let's just check D. 2 and 16 are zeros and indicate the number of tickets sold, which the profit is $0. Well, it doesn't say anything about the number of tickets sold. It just says ticket price and profit. So C, where 2 and 16 are the zeros, indicate the ticket price for which the profit is 0. So I mean, if you set tickets at $2 a piece and sold out your concert, you would have a $0 profit because the amount that you put into the concert would equal the amount that you got in revenue. So we would have a $0 profit. Same thing with $16. $16 would be just about too high because you're making $0 profit. Alright, so 2 and 16 are the zeros because that's when the ticket price for the profit is 0. Look at the function below. Which of these describes the range of this function? The range is the set of all outputs, or y values, of the function. Alright, so it looks like we could use any x value we want for this function on the real numbers. But we will never get a y value, or an answer, or an output that's below 0. Well, this function indicates that this never goes below 0 as a y value. So y will always be greater than 0. And again, this don't confuse this. This is the domain. I'm just thinking. We think domain, left and right. And when I think range, how low and how high can the values be? Min used the graph below to show the average cost of a school lunch is increasing at a rapid rate. Which of these best describes why this is a misuse of statistics? Alright, so this gets into a different core learning goal, a misuse of statistics. But I threw it in here because it's reading a nonlinear graph. Alright? So, why is this a misuse? Okay, so it's telling us that min is wrong. Alright, it doesn't show an increase at a rapid rate. So let's take a look at it. Alright, has years on the y-axis, which is usually a red flag because any amount of time is usually the one that goes on the x-axis. And then the y value is the things that's a result of the time changing. So that's our first red flag. Cost is on the x-axis. And so we see at 1999, lunch costs about $1.75 on average. In 2000, the lunch costs on average $2.25. 2001, it cost $2.50. 2002, it cost $2.50. And 2003, it also cost about $2.50. So to say it's increasing at a rapid rate is incorrect because for the last 3 years, it stayed the same. It just looks like it on the graph because of the way she has it drawn. So the cost of school lunch is actually decreasing? No, it's not decreasing. It's staying the same once it gets to 2001. A line of best fit should be used instead of the graph. You can make an argument for it, but it's probably not going to be the best answer. But we won't cross it out just yet. The graph should not include the years where the cost stayed the same. Well, that's an important part of the graph because we need to know if the school lunch went decreased or increased or stayed the same. So it's important to include those. The years should be placed on the horizontal axis to show how the average cost of school lunch changes over time. That makes a lot of sense. Alright, so it's J. Again, the first red flag is the x value is usually going to be the amount of time in any case, because you're trying to show how something changes over time, not how the thing that changed went. I can't even find the words to explain it because it doesn't make sense. So just remember, time should be on the x-axis. Students take a math exam before entering a certain college. The graph below shows the relationship between the student's scores on the exam and their math levels. So Kalia earns a score of 80. What is her math level? Well, all this is good and fine. We don't really need to know. I mean, it helps us introduce the problem and what we're looking at. But basically the question says she gets an 80. Alright, so here's her score. We want to know what her level is. So this is the big question mark. What level? 1, 2, 3, 4, or 5. Alright, so we find out where 80 is. Follow it up. Alright, we notice that the first thing we come to is an open circle. That means the graph here between 60 and 79.9999999, her math level will be considered a 4. But as soon as she hits 80 on the exam, her math level bumps up to a 5 because this circle is filled in, meaning that the point 80 is included at this part of the graph where the score level, or where her math level is 5. So open circle means it does not exist at that point. Closed circle means that that number exists at that point. Alright, so her math level is a 5. And that wraps up 114 and 124.